Good morning, everyone, and welcome to part 4 of the Safety Studies course. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation in this training. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the course presentation, please use the questions box to send in any questions you might have, and I'll be dispatching those periodically to the instructors. Please note also that the handout section of your GoToWebinar panel includes PDF copies of the course presentations for reference. With that, we will go ahead and turn things over to Alex Maestros, who is our primary instructor for today's session. Alex, hello.
Good morning, Mike. Thank you for the introductions. And good morning,
Yes.
everyone. We're happy to be here for the final of the Safety Studies modules for the Traffic Academy. My name is Alex Maestros with Jacobs Engineering Group. My co-presenter who's managing the question chat pod for today is Cindy Yerke, who also presented yesterday. Feel free to utilize that questions box or the chat pod box, whatever we're calling it here. And we'll have somebody kind of manning that live, and then we'll also use that as a way to kind of break from the presentation and address questions to the larger group. As a reminder, in order to receive the full credit, attendees must attend and complete all 4 webinar sessions, and then successfully complete an online test that will be emailed out to you after the completion of this course. And Mike will have a note on that again at the end of the presentation here this morning. So here in Module 4, we're going to cover performing relevant traffic studies, identifying and evaluating countermeasures, which will be our big ECAT demo. And then finally, we'll talk about the development of the actual plan itself and how to finalize a report. But before we jump into too much of that, I did want to take a quick jaunt back to last Friday, where you might recall we kind of ran up against the end of the class, but I wanted to make sure we properly covered EPDO value and EPDO crash rates. And so EPDO, or equivalent property damage only, is a method of weighting crashes based on their severity. The weights of the different crash severities correspond to calculated human capital costs of average human capital costs of those crash severities. So we can see each crash has an associated value, and this is a determined number from statistics around the country that are then applied to the state of Ohio. So each crash has a cost, and that cost can correspond to the PDO cost. So in essence, we're trying to say, from a human capital cost calculation, what's the equivalent between each severity of crash and a property damage only crash? In the state of Ohio, as of right now, we're using a 4-code EPDO system. This means that K and A crashes receive the same weighting. The purpose of this is really just to acknowledge that KA crashes are very similar in their circumstances and contributing factors, and that the difference between a fatality or a serious injury may very well come down to the individual that was in the crash. So you can see the weighting for K and A crashes is 36.66, and we have decreasing EPDO weights as the severities become less and less and trend towards 1 for our PDO. So what we're saying here is 1 property damage only crash is equivalent to 1 property damage only crash, where 1 fatal or KA crash is equivalent to 36 plus PDO crashes. So the benefit of using this in something like calculating a crash rate is that we're able to look at all of our crash data, regardless of severity, but then focus or weight things towards our KA crashes, which is the focus of the HSIP program. So the way that we will calculate an EPDO crash rate is to come up with the EPDO value for all our crashes. So we'll multiply individual crash severities times the weighting factor, and those weighting factors were what I just presented on the previous screen. And then we're really just running through the rest of a crash rate calculation here. So this first section is calculating that EPDO value, and then we're multiplying times 1 million vehicles. This crash rate is going to be crash rate per million vehicle miles. We're dividing all of that by the years that are in the study, so the years of safety data that we're after, typically 3 or 5 years, times 365 days, times our average daily traffic in the section that we're calculating the rate for, times the length of the segment in miles. So again, we have a crash rate, but instead of just using the number of crashes or the number of KA crashes, we're using weighted values based on equivalent property damage only calculations. So why do we need an EPDO rate? Well, A, it's a great way to understand the severity of the crash rate that we're looking at. It helps to use all available data, particularly as we start looking at larger network analyses where we want to make sure that we're getting coverage of our calculations and our rates, but we still want to skew towards the KA crashes. And then this is also currently one of the scoring criteria when we go to apply for HSIP funds with ODOT. And there will be updates kind of throughout this summer on EPDO rate and some of the other metrics used for scoring projects, but important to understand the concept of EPDO rate and how this can be an advantage in terms of displaying the severity and frequency of your crashes. All right, so moving into the actual meat of Module 4 is performing relevant traffic studies. Up to this point, we've talked about a lot of analyses. We've talked a lot of background information on the Highway Safety Manual. We've talked a lot about how to scope out and how to collect data for your safety study. One of the things that we had talked about when we were in the data collection mindset was what data don't we have? Do we have anything that tells us about queue lengths or congestion, or do we even have valid traffic data? And so step 3 of the process is really, we've gone through safety data collection and we're diagnosing crash patterns. We're identifying the potential for safety improvements and potential countermeasures. We're doing that heavy safety analysis, but this is the point where we're talking about what else needs to be done at this site, maybe from an operations standpoint or maybe in support of potential countermeasures. So step 3 is rather straightforward. The first thing is, what appropriate studies do we need? Are we looking at a signalized intersection where we need to analyze capacity? Are we looking at an unsignalized intersection where we need to do a signal warrant analysis? The key is these types of things, while we frequently do them within a safety study or in supplement to a safety study, are not necessarily a part of the safety study from the get-go. So again, really key that we're working with ODOT DSRTs, our safety representatives, and our local highway agency or local authorities in general. So we want to select supplemental studies or analyses, again, including volume analyses, signal warrants, capacity analysis, maybe site distance is another one. But we really want to select these based on crash patterns and existing conditions. We don't want to include a signal warrant analysis just for the sake of including it in here because we're already here. The idea is that this is in support of the safety study. And the other thing is we really want to focus these on locations with the greatest potential for safety improvement. So once we've identified that PSI from step 2, the additional studies really are in support of advancing towards ideal countermeasures or improvements at the sites. And then part A of the safety analysis guidelines has a comprehensive list of studies, so definitely refer to that in preparation or figuring out what these supplemental studies should be for your site. So again, once you've come up with your recommendations for relevant supplemental studies, take those to the DSRT and project managers and make sure everyone's on board before we start to do those studies. It might be that, hey, we understand that we're going to do a queue length study here in the future, but it's not really applicable to this safety study based on the crash data that was presented or based on our ECAT analysis to this point. Really just comes back to knowing your study area and a lot of the times conveying what we don't know about our study areas. And that's why we're reaching out to the DSRTs and to our local partners to kind of help fill in some of that local knowledge. And again, in terms of other traffic studies, there are literally dozens of other courses we could go into on this, but definitely refer to ODOT's traffic engineering manual, ITE manuals, the Ohio Manual of Uniform Traffic Control Devices, FHWA and AASHTO guidance as well in terms of how those other studies should be conducted and how they're relevant to our individual study site. But I think the big thing is, instead of focusing necessarily on how to complete those, it's how do we incorporate those? So within the safety study itself, and we'll go over this when we start talking about assembling the document in a lot more detail. But we want to make sure that we're presenting these in the safety study as supplements to the safety study. We don't want to take over the safety study document or the conversation about this site in terms of any of these other supplemental analyses. We want to make sure that we're presenting the relevant data in the study itself, and we're showing how it has a potential impact or a link to safety, or perhaps how we're identifying causes of crashes through these additional analyses. In the appendix of the document itself that we create is probably a better place to incorporate a lot of the technical data or calculations for these supplemental studies. But the mindset really is, how can we quickly and easily convey the results of these studies as they impact the safety study? So this is a pretty cool diagram. So this is a site where we have an interchange close to a major three-leg intersection, and we're going to assume to be the north side here. And this was an observed queue study. And so there was obviously a lot more detail, data collection, and parameters for calculating and observing these queues. But one diagram really and quickly kind of shows where traffic backups are occurring. And so in the realm of the safety study, it's really easy to see, okay, we performed this queue analysis, and quickly and easily, this is how these were the results, and we can quickly draw ties back to a safety analysis from this point. Whereas that additional data, we would look to be either in its own standalone report if it was substantial enough, or just in the appendix of the safety study. Alrighty, so the big thing in step 3 is really just understanding what other analyses need to be completed to support the safety analysis, and then thinking about the appropriate way to document those. And all along, we want to make sure we're conveying those ideas on what studies to do and how to incorporate them with the DSRT and the local highway agencies. And in some cases, step 3 may be known when we look at the crash patterns or when we're collecting data from the get-go. It may not be a linear process that we've gone through step 2. Now we're thinking about step 3. It may very well be that, as soon as we get to a site for a field visit, it's clicking that we've got backups occurring in consecutive intersections or something where we really need to have a better understanding of the operations. So having a full understanding of this process really helps to get ahead in the right way. So step 3 is identify and complete supplemental analyses. All right, so step 3, again, it could be completed in a linear fashion, or maybe we're doing this even before we get to the safety analysis summaries, but again, we're supporting the overall safety study process. Step 4 is to identify and evaluate countermeasures. Step 4, you'll notice, is the last in our continual cycle of trying to come up with our final plan. It may be, we've done a relevant study, we think we have an idea of the correct countermeasures, we go to evaluate them, and the results weren't exactly showing us what we want. So then we can come back through and, we'll go through this cycle until we have identified potential recommendations and treatments to address our safety concern. So step 4 is another step back into the highway safety manual. The overall goal and the procedure we're looking at is we want to talk about modifying that crash prediction based on traffic engineering study results by adjusting Part C CMFs or Part D CMFs. I know last week there was a couple of conversations over Part C CMFs, Part D CMFs, and that's totally normal, particularly if you're seeing this for the first time or you haven't worked in the highway safety manual. Part C versus Part D CMFs is a common kind of, I don't want to say tripping hazard, but it's something that has been acknowledged that the wording wasn't quite right in the initial HSM and it's being changed. But hopefully as we go through, particularly the example in ECAT in a few minutes, everything will kind of fall into place. But basically what we're trying to do is say we've modeled our existing conditions. Now we're going to see if we change certain variables or implement treatments at a site, how is that going to change our predicted safety performance at our individual site. So again, we're going to rely on the Highway Safety Manual, or here in Ohio, we have the benefit of relying on the ECAT tool to kind of guide us through the HSM process to complete the calculations. Again, the goal is that we want to lower the expected number of crashes so that it goes below the predicted. So we talked last week about PSI, and we'll go over here again in a minute, but the goal is to really address that potential for safety improvement. And then one of the ideas that we want to start incorporating when we talk about evaluating our countermeasures is the benefit cost analysis. You know, we can, in a lot of such circumstances, the limitations on the improvements at a site are related to, you know, the costs. And are the costs going to outweigh the benefits in terms of reduced crashes? From that standpoint, when we start making recommendations, we really do want to start with our low-cost, short-term improvements. The signing, signal timing, pavement markings, pavement friction to a certain extent, and vegetation removal, things that can be quickly implemented and at a lower cost. If those are going to show a positive reduction in crashes, then we definitely want to make sure that those are being implemented first. Alrighty, so this is a quick refresher from the predictive method on last Friday. Step one was to determine our data needs and then identify our individual HSM sites. If you'll remember, the step in the actual calculating of crashes was, number one, we're going to calculate a predicted number of crashes based on the site type for the base conditions. So if we're talking about a rule two-lane intersection, we're going to calculate the predicted number of crashes just for an average typical base condition site. Next, we're going to calculate the predicted number of crashes for our particular site by adjusting some of those base conditions to reflect what's actually out at our specific rule two-lane intersection. And then finally, we're going to incorporate that historical observed crash data to come up with an expected number of crashes for our particular site. So step three, again, is where we start to incorporate the crash history using the empirical Bayes method to get the expected number of crashes. As we'll see in a few minutes, ECAT really helps to complete steps 1, 2, and 3 almost simultaneously. It really does make the process very simple and approachable. All right, so we previously mentioned PSI. So the PSI is our potential for safety improvement. If the black line is the predicted crash frequency for our site that we calculate after step 2, when we apply our observed crashes at the site, it helps us to adjust that prediction for our particular site. This is really the best of both worlds because we're saying how did the site perform on average for typical sites, and then by incorporating the observed crashes into that expected average crash frequency, it's saying, well, how is this particular site performing compared to what we would have predicted? So when we incorporate the observed crashes through the EB method, if we're seeing that the expected crash frequency is higher than the predicted, then we have an excess expected crashes or a potential for safety improvement. Likewise, if we have a very few number of observed crashes at our site, it may adjust the expected average crash frequency below the predicted value. In this case, we don't have that potential for safety improvement. What we're saying here is this site is performing better than we would have predicted. Alrighty, and so we had previously mentioned once we have, that baseline safety analysis done, what we're going to look at is how can we try to improve safety performance at our individual site. And what we want to do is say, well, what treatments can we implement here? And the way that we'll model treatments is kind of twofold. It'll be through observed and, it'll be through the implementation of crash modification factors. So we're going to get back to the Part C, Part D CMFs, but basically CMFs, crash modification factors, are ways to say this is the proven safety benefit, or this is how this safety treatment has a proven benefit for a given installation. Part C CMFs, when we talk about adjusting and proposing conditions, really has to do with our specific HSM site type. Part D CMFs, again, they don't apply to adjusting the predicted value. It's a treatment that we're going to apply to the expected crashes at the very end. Part D CMFs, you'll see in a second, we could also apply to observed crash history if we can't go through the predictive method. So kind of jumping off from that point, there are different methods for estimating safety effectiveness. As this list increases, we get into more reliable estimations of what the estimated safety effectiveness will be for a given treatment, or for a given implementation, I should say. So the very bottom of this list, we see observed crash frequency and Part D CMFs. So if we have a site type that is not currently, that doesn't have an HSM site type, something that there just is not a predictive method for yet, we can take our Part D CMF, which comes from the Crash Modification Factors Clearinghouse primarily. We can say, okay, well, we know that if we install flashing beacons at this site type, the CMF Clearinghouse says we'll have a 25% reduction in crashes. If we don't have an applicable HSM site type, we can apply that directly to our observed crashes. We can take that Part D CMF and apply it to the observed crashes. However, applying directly to observed crashes doesn't really account for things like regression of the mean bias. It doesn't give us the most accurate depiction of our site safety performance. And that's the reasons why we like to go through the EB method. So the next more reliable method would be looking at just the SPF. So let's just look at the predicted value for crashes here and not incorporate observed crashes, and then apply our Part D CMFs. So the reason why we would do this is if we just don't have any crash data available. We're not sure if it's incomplete, if it's missing, or what. But we can use just the SPFs to and apply Part D CMFs to them to get an idea of how the predicted safety performance could be improved. This is also applicable when we are dealing with a new feature, a new roadway, or something where we don't have a crash history because it's not modeled or it hasn't been built yet. So there's a couple other variations. We can do the predictive method with Part D CMFs, the full predictive method where we're adjusting our site with Part C CMFs and Part D CMFs. But what we really want to focus on is developing that full EB method. So going all the way through steps 1, 2, and 3 of the predictive method and applying our observed crash histories and coming up with our EB expected crash frequencies, and then applying Part D CMFs and Part C CMFs. So it's a lot of different language being thrown out there, and it might seem like these are a lot of, like, the menu is really long in terms of understanding how to evaluate countermeasures, but hopefully we'll see here in a few minutes through the use of ECAT and kind of going through this a few times. It's actually more complicated to try to explain the different variations than it is to kind of show you how Part C and Part D CMFs play together to show us what how site implementation might improve our crash frequencies. So one more time, just kind of going through the difference between Part C and Part D CMFs. Part C CMFs are developed in conjunction with the SPFs for base conditions and are used to adjust base conditions to site conditions. Part D CMFs estimate the effectiveness or the expected change in crashes as a result of implementing countermeasures. This is, again, Part D CMFs include Part C CMFs, but Part C do not include Part D. So Part D, we only want to use when we're talking about implementing countermeasures. We don't want to use that in terms of adjusting our site prediction to what's out there in the field. Whereas Part C, we use those to adjust base conditions to our site conditions, and then we can also use Part C if they're available to show proposed treatments. So one last time, Part D countermeasures are only applied to the proposed conditions, where Part C works both ways. It can apply to the existing and the proposed. And luckily, again, we have ECAT to really walk us through how to incorporate Part D and Part C CMFs. Righty. In a minute, I'm going to run through our ECAT example and tie all this together, but I do want to stop real quick and see, Cindy, do we have any questions or anything that we need to cover kind of on in the material so far?
Yes, there was one question that we received from your recap of the material from last week, and I don't know if you can see that comment or not, or do you have access to see it?
I cannot. Can you read it for me?
Sure. It has to do with what you discussed with your 3 EDPO or your EDPO discussion. And the question is, did Alex say that Ohio uses the 3 EDPO code factors for the EDPO rate calculations? I don't recall what you were saying at that specific time, but did Alex say Ohio uses the EDPO 3 code factors for the EDPO rate calculation?
Sure. So good question. Thank you for letting me come back and clarify. So I think we're referring to this chart right here. And this shows a couple of different ways that we could look at EPDO, where each crash severity could have its own factor or our own code, so its own weighting. Ohio currently, as the safety analysis guidelines are written and the way that we look at scoring benefit for ECAT and things like that, we use the 4 code. So we're grouping K and A together, and then B, C, and O have their own weighting values.
Thank you
Anything
very much.
else?
All we
Anything
have.
else in terms of questions, Cindy? Okay.
Definitely.
Alrighty. The good news is that is the last arbitrary theory that I have to run through. And trust me, I'm as excited about that as you guys are. So right now, what I want to do is run through an ECAT analysis from beginning to end almost. I know normally this is a really interactive part of the class. So really encourage you, if I've gone too fast or anything like that, or if I'm clicking and things aren't lining up as I'm clicking and the screen isn't there, or if you just got a question on exactly how something popped up or where it was, please throw a chat in there. And then I'd encourage Cindy, Mike, interrupt me as much as we need to make sure that we're getting this kind of interactive discussion on using the ECAT tool. Alrighty, so the example that we're going to run through is out in Allen County, State Route 117 at State Route 501, Spencerville Road at South Wampakoneta Road. This is one of the examples that's available on ODOT's Safety Analysis Guideline website. So if you need to refer back to it in the future, that it should look pretty familiar. I have updated to the newest versions of ECAT and the CAM tool, which we always want to make sure that we're doing. All right, so this is our site is this intersection. I guess for a little bit of context, you can see we are just slightly south and really west of Lima out in Allen County. This tool, this site actually has been updated. So the updates that we're going to run through have actually been implemented at this point, but luckily we can use ODOT historic, or Google historic satellite imagery to kind of show what the site looked like. So this is back in 2016. For the sake of this example, we're going to pretend that we're doing this analysis in 2016. And so what we have is the main line of a Rule 2-lane intersection. The site is pretty easy to identify. We're definitely in a rural area. You can tell by site context. Also in the field, you also want to verify that your site types are right. So if we got in here and we had lots of curb and gutter and there was sidewalks, despite the fact that things look pretty rural, we would want to start having that conversation over what's the best way to capture these site conditions. But this is a Rule 2-lane intersection. Our main line is 117. And then you can see that the minor legs are stop controlled. Other than that, it's a pretty typical rural skewed intersection, a pretty significant skew between 501 and 117. And for the sake of the example, I'm privy to some data that we've collected in advance of this. But the first step is to navigate back to ODOT's crash analysis tools. And then you can see, if you remember back to last Friday, this is where we have our information on GCAT, our CAM tool information, and the CAPE tool is a new tool that ODOT's going to be unleashing, and so it'll be out here in a little bit. And then the ECAT tool is, I don't know, halfway down the page. And so the great thing about the ECAT tool is we do have the latest version of the tool here, along with a lot of examples in different site types, which are great references if you're working through your sites to kind of see, okay, this is how they did, you know, various other site types. And then there is specific ECAT help files to help walk you through this too. The number one thing I can say about the ECAT tool is it's designed to help you work through the processes of the HSM. There are definitely background thoughts, data collection methodologies. There's just general questions really need to go back to the Highway Safety Manual itself. ODOT's the tool to help us get through the analysis, but it doesn't have all the answers. We definitely want to make sure that the Highway Safety Manual is handy and we are comfortable kind of paging through it and seeing, okay, I'm working in chapter 12. This is where I can find additional guidance on, you know, what does skew angle really mean? So we've downloaded our blank tool. We go to open it up. We initially will get this landing page. Good thing about this is it'll always have the version stamped in it. Again, we want to make sure that we're going and pulling the newest version of ECAT. Derek and his team are excellent on making sure that the tool is staying up to date in terms of functionality, and anything that is a mild or a small change gets updated into a new version. All of this information on the front landing page, on the instruction page, is super helpful to remembering how I'm supposed to do everything, but I'd say the real magic begins here on the next tab, which is the project information tab. I have filled in a few bits of information here just to make sure that we end up at the right place. But basically, when we're looking at our site, we know that we want to widen for some left turn lanes and we want to realign to correct the skew angle. And then we're going to also add some flashing beacons so we can see, mainly so we can see how the Part D CMFs play in. So make sure that we're putting in all the above information. Always make sure the contact information is included. These tools often get passed on to our local partners and then to district or central office, and it always helps to know who is the point of contact for developing this information. So yellow in the ECAT tool indicates sites or cells that we need to input information. Blue indicates sites that are pre-populated, but we have a question that we need to answer, or we need to select an answer. So the first question is, are we going to perform benefit cost analysis? Since we're going to run through an entire study, both from identifying PSI and then we'll look at implementing countermeasures, for the first go around, we're going to say no. At this point, we're just going to evaluate our existing conditions and determine what is the PSI for our site. And do the proposed improvements fundamentally change the conditions of the base performance, or the base safety performance function, or is crash data unavailable, or is only the predicted analysis needed for the existing proposed condition? So I'd previously run through this slide on kind of the different ways to evaluate countermeasures, and this question is a much easier way to kind of digest how we're going to evaluate these countermeasures. And we can really just think, what do we have available to us and what are we suggesting at this intersection? For the sake of this one, we're going to say no. I mean, we're not really fundamentally changing the base condition. We're still going to have a rule 2-lane intersection. We know crash data is available. I've already pulled it. And we know that we don't just need the predicted analysis for the existing or proposed conditions. So we're going to type no in here, and you'll see all of this is macro driven. So lots of things update in the background. Got to make sure that macros are enabled when you're using these ODOT tools. So we're looking at one intersection site type. We've already mentioned that it is a rule 2-lane, 2-way intersection. And we know that it is minor leg stop controlled. And so it is unsignalized. You can see when we selected an intersection, this cell here kind of grayed out. That's because we don't need to input an endpoint. If we have a segment, then we want to specify the beginning log point and the end log point for the segment. But for intersections, we're just concerned with the intersection midpoint. So again, the intersection midpoint, this is something we can find on TIMS. It's available background data for us. It's under the roadway information tab. I know ours is 10.76. And then two things that we need to identify for intersections are the NLF ID of the major leg and then any of our cross legs. I've already populated this in here because I want to make sure I don't mistype those. Eventually, when we get to uploading the crash data into this tool, we want to make sure that these NLF IDs are correct as they would be seen in the CAM tool. So again, in the process of going through our safety study analysis, we're going to do a CAM tool first. And one of the reasons why we're going to review that and really make sure those crashes apply is because that data will then get uploaded into the ECAT tool. And so NLF IDs, we definitely want to make sure are correct. Now, as a quick refresher, as we're looking at TIMS, we can pull the NLF IDs. This is our site again. Let me clear out the crash data. But if we want to pull our NLF IDs for our roadways, we can go to road inventory layer in TIMS, and we'll see the different colored lines appear. Now, to actually figure out what the NLF IDs are of this road, we can hit the identify features button and then just click. So if we click on our major leg at 117, we can see that our NLF ID is the second value listed here. Now, this is a great example of why it's good to go into TIMS and make sure that we are confident with what we're dealing with. The southbound version, or 501, or the minor leg to the south, I should say, is State Route 501. So it's State, Allen County, State Route 501. But on the north side of the road, it's actually Township Road 91. This is important. Again, we're going to be pulling the information for the crashes to associate to this site in a minute based on NLF ID. So we want to make sure in ECAT, we have the major leg is State Route 117. But as far as the cross route IDs, we actually want to type in both. So you'll see if we hover here, we get this helpful hint from ECAT that says add up to 5 cross route NLF IDs to assign side street crashes to a project element. And we're going to separate each NLF ID with a single comma, no spaces or anything. So here we've got the State Route 501 NLF ID and our Township Road 91 NLF ID separated by just a comma. All right, so that is as technical as it gets for defining our site types on this page. The last thing that we want to do is just give it a common name. The common name, really just a way to help us remember and understand which site we're looking at. If we have a corridor or a project that we're analyzing that has a lot of segmentation in it, the common name can really help us remember kind of where we're at as we go from tab to tab, as you'll see in a few minutes. So State Route 117 at State Route 1 / Township Road 91. Alrighty. So we have our one site. All we're going to do is analyze the intersection at this point. We have a couple different options. So we have a toolbox up here, which, if I load it, the toolbox shows us in order some analysis processing steps. The first one is load crash data from a CAM tool. The second is to assign crashes automatically to project elements. Third, we'll add or remove analysis worksheets. And the fourth is to create project summary reports and benefit cost analysis. So we have that option, and then we also have go to crash data worksheet. And if we know we don't have crash data or we're not entering crash data, kind of one of the questions we've answered up here, we can just, here's the question, not entering crash data, generate the analysis worksheets. For this site, we're going to go ahead and analyze or add our crash data to the worksheet. So we can click this black arrow. What that does is it unhides and it opens up our crash data tab. You can see again, our toolbox is still available handily, always will be the same no matter where we see it. But then we have the quick button to kind of immediately jump to loading our crash data. If we click this black button that says load crash data, we'll get a prompt to select the CAM tool file containing the project crash data. So the way that ODOT has developed these tools, they really build on each other. We're going to pull that crash data from TIMS, and then we're going to load it into a CAM tool. That's part of the analysis process. It helps us make sure we've reviewed our crashes and helps us to initially summarize our crash patterns. But once we save that tool, now we're going to make sure that it's handy and we don't just get rid of it, because we're going to use that to import the crash data into ECAT. So when you hit OK, we'll have our file manager pop up, and then we look for the CAM tool for State Route 117 at 501. We'll hit open. So then we'll get a notice that crash data is loaded. You are ready to assign crashes to elements. Alrighty, so we see this is our crash data. If we were to open up the CAM tool, we could verify this. One friendly user tip, don't have the CAM tool open when you're trying to import the data into the ECAT tool. Sometimes it can cause an import problem, so it's best to just close out of the CAM tool during the import process. And then if you need it back open, just go ahead and open it back up once the crash data is loaded. At that point, the data is in ECAT. It's not like we're reading data from the CAM tool still, so they're totally separate tools as soon as the data is imported. Alrighty, so once we have our crashes in here, the next thing that we have to do is assign them to the project elements. And what we mean by project elements, if I can go back to the project information page, you'll see all the way to the left of this project element description table is project element ID. This is automatically created as we typed in the site type, we selected the site type, we selected control type, and then we entered our common name and we entered a log point, and that's really what populates this this element ID. Each element that we have defined here will have its own unique element ID. And so it's more or less each site type within our study is going to have its own element ID. So what we need to do is assign crashes to the particular sites within our entire study. We can do this manually by entering the name of that unique element ID, or we can open up our toolbox and we can, the second button down in the analysis processing is assign crashes to project elements automatically. So if we click that, ECAT will, based on the NLF ID and the log point of the crash, it will associate that with the intersection or segments that we previously defined on the project information tab. So go ahead and click that button. You'll see all of our crashes have been assigned to the state route 117 semicolon 10.76 site ID. That is simply because it's the only site that we have in here, and you'll note all of our log points, or excuse me, all our NLF ID and log points, in this case, happen to fall on the main line and within a boundary. Now, if you're saying, how does it know where to put those? We've kind of helped it out. For a segment, it will place it based on the primary NLF ID and in between the beginning and the end log point. For an intersection, it will look at the NLF ID main point, or excuse me, the NLF ID of the mainline route and the midpoint of the intersection, and then it'll actually search within a radius of that intersection or along minor routes or cross routes based on NLF ID. By default, this is 0.05 miles. You really should do an investigation of your site to determine if this is appropriate for your intersection. In some cases, if we have really long left turn lanes, or if we have the intersection starting pretty far away from the actual center point of the intersection, we might need to adjust this. Or likewise, we might need to just assign these manually. And that's really making sure that we're looking at the HSM and identifying how to identify really that influence area of the intersection. And that will change based on our site types, and it'll kind of change depending on the exact layout or configuration of our site. But specifically, since we're looking at one location and we've verified all of these crashes, we know that they're all going to line up here. All right, so once all of our crashes are associated to the correct intersection or segment ID, the next thing that we want to do is to generate the actual site analysis sheet. So we'll open up our toolbox again. And then the third button down in our analysis processing portion of the toolbox is add or remove worksheets. If we click this, we'll see the screen kind of updating. We'll get some messages down here in the bottom left-hand portion of your screen. Always keep an eye on this. It may look like your computer's not doing much, but if there's ever a note down here saying what's going on, we want to make sure not to kind of interrupt the macros as they run. All right, so the macro has run completely. You'll see we have a new tab in brown down here, and it's kicked us back to our project information tab. So going back to the project information and seeing our new state route 117 tab indicates that the macro ran successfully. So what we want to do at this point is we want to go through each of our individual sites, or in this case, our one site, and fill in the appropriate information for that site. All right. So within the element tab, or each individual site's new analysis tab, there's a lot of information going on. At the top, we have the information that we input into the site information, or the project information tab, or the site information. We have another set of boxes down here with some blue and some yellow input boxes, so we know we're going to need to do some inputs here. And then we've got a lot of information in terms of numbers and formulas, and a lot of detail that we can show, different color coding. And I think the great thing about the ECAT tool is, in terms of inputs and checks and balances and anything along those lines of implementing the HSM, we're really just concerned with these blue and yellow input boxes in the very top here. So this is one of the great ways that ECAT has kind of simplified, or not kind of, definitely has simplified the implementation of the HSM. So we have these different checkboxes, or these different inputs to go through. Note that each site type is going to have slightly different requirements in terms of inputs that we have to enter. So again, when we know our site types at the very beginning, when we're scoping this out, we're collecting our data for the EB process, we need to make sure that we're going to have the appropriate data through our data collection process to answer, these few questions here. So we know the intersection type is a 4-leg stop controlled, or a 3-leg stop controlled is the other option. If you are concerned or you're not sure exactly what we need to put here, A, go to the highway safety manual, but B, as we select an option, so we selected the 4ST, we can see we have an unsignalized 4-leg stop controlled on minor road approach, pops up here in column P. If we switch it to a 3-leg, again, this updates to an unsignalized 3-leg stop controlled on minor approach. So we do get some, again, a helping hand from ECAT, but ultimately we're just trying to simplify the HSM. So we know this is a 4-leg stop controlled intersection where the minor road approaches are stop controlled. Sorry. Next thing is we want to enter the ADT for the major and the minor legs. Luckily, we did a traffic data collection before we kicked this project off, and so I've got those real quick. 5, 6, 3, 1, 6, 8. Again, we want to operate within the bounds of the maximum ADT as defined by the Highway Safety Manual. If you are slightly over, good time to have a conversation with DSRT, maybe with central office, to determine, does this still apply? Next question is skew angle help. So the skew angle, again, we want to refer back to the Highway Safety Manual, but we do have, ECAT took the skew angle measurement graphic out of the HSM and put it right here for us. So skew angle is really just a measurement of the angle of departure away from perfect 90-degree intersections. And then the first question is the skew angle different for the minor legs? When we go back to Google Earth, we can see, the skew angle is the same for the minor legs on the way through. We don't have one coming due north and one kicking way off at a different direction. So no, the skew angle is not different for the minor legs. So then the skew angle for leg 1, we're going to call this about 45 degrees. No need to bring the survey crew out. It's a reasonable closest answer will work. But we can see that's about 90 degrees, and so we're really bisecting that 90 degree. So we're going to call it 45 degrees. And the skew for angle 2 is also 45 degrees. Next question is, what is the number of uncontrolled approaches with the left turn lane? As we look at our major and minor legs, you can see we don't have any turn lanes right or left on the uncontrolled approaches. So that's 0. And again, number of uncontrolled approaches with the right turn lane, still 0. There are no turn lanes present at the existing conditions. And intersection lighting, it looks like there might be a Cobra head here for intersection lighting. We have no lighting present is the baseline condition that we're showing based on street view that we had at the time. So we're just gonna say not present. And the last question we need to answer is, what is the locality? Is this on the state system or off the state system? And because we have an intersection of 2 state routes, we know it's on the state system. If you're unsure about that, obviously feel free to reach back to DSRT, or Tim's is really great in terms of helping because we can look at, you know, all the NLFIDs entering an intersection or for a segment. All right, so we've answered all of the input boxes here for our site. So the question is, now what? We had a lot of calculations that we were supposed to do according to the HSM, right? It was find our base data, and then we had calculate the base prediction, calculate the prediction at the site, calculate EB. So in terms of data input and figuring out what to apply to each of our sites for the existing conditions, that's as much information as we really need to input before we can understand the analysis of this. So a lot of information in the HSM, a lot of information on how to apply the predictive method in part C, but really it comes down to collecting the right data and inputting it into these data cells here in ECAT. So one thing that I wanted to point out at this point is, what about all of this stuff? You know, we have all of these red, these purple, eventually we'll get to orange, and these are all cells that are carrying and holding these are all cells that are carrying formulas that we need to work through. So as we change variables and input variables into this section, these calculations will all populate and update. In terms of applying those Part C CMFs, that's what is populated when we enter some of this information. So the very next line down here, you can see we have CMFs, or these are the Part C CMFs that we're applying to this location. We didn't have to go out and select the Part C ones. We didn't have to worry about how to apply them. All we have to do is focus on answering these relatively simple site questions. But you can see that we have a CMF populated for intersection skew angle. If there wasn't one there, if there was no skew, you can see that our CMF is 1.0. But because we have that skew of 45 degrees, you can see that we're indicating that there is going to be an increase in crashes. So that's how we apply Part C CMFs. So as we're talking about the baseline safety analysis, if we want to get a report of what is our PSI, right? We've done the data input. Technically at this point, we've done all the information we need to understand our existing conditions. We can create project summary and benefit cost analysis. So if we click that last button in the toolbox after we've inputted all of our information, we'll get a note that says the required summary reports have been generated, and it'll take us to the report site. So at this point, we've completed our baseline analysis, and this is how the HSM Part C kind of is done in ECAT and reported back to us. This purple bar, this is this red bar for total crashes or for our individual severities is the predicted crash frequency at our site. So this is that site predicted crash frequency based on our particular site. We've adjusted it with the Part C CMFs, and we're predicting 6 total crashes per year. And then we have next to it this purple bar, which is our expected average crash frequency. Because we imported that crash data and we assigned it to our sites, EB is run almost at the same time. It's as soon as we finish the predictive method, as long as we have the crash data in here in ECAT, the expected number of crashes is populated for us, which we can see when we add in our observed crash history, our particular site, the expected value is actually higher at our site. And so the expected crash frequency at our site is 7.1 total crashes per year, and the predicted is only 6.0 crashes per year. So our potential for safety improvement is 1.1 crashes per year. Again, PSI is the difference between expected and predicted crash frequency, and ECAT really quickly summarizes all of that for us. All right, so that's how we develop our PSI and understand, yes, there is a need for a safety improvement here. But what if we want to go and actually look at that safety improvement? So again, we want to talk about widening left turn lanes and realigning to correct skew. So the way that we can do that is, let's quickly just say yes to our benefit cost analysis. So we can do a benefit cost analysis directly in ECAT. One of the things that we need is a traffic growth projection. Just input some base data here. You can get all of this information again by talking with district and understanding how the site is intended to grow. All right, and this popped up because we hit yes to the benefit cost analysis. So now if we go back to our site, nothing's changed here. But as we scroll through, we get to the reds. The purple section is actually the calculation of our EB stuff. And then we get to this yellow. And this is the exact same field that we saw above, but now we're talking about proposed conditions. So here is where we can start to say, okay, we're gonna add left turn lanes on the major approaches. That's something that we're going to implement in the proposed conditions. So this is how we're changing the site conditions in the future. And then we're also going to realign to remove this skew. So we'll get rid of that. And so again, we're talking about the proposed conditions that are specific to this site in the EB process. And so now if we go back to our report, we didn't have to rerun anything. It's all updated automatically, but by making those adjustments in the report, we can see that our proposed conditions, by adding those left turn lanes and realigning to remove that skew, our proposed conditions are now showing an expected average crash frequency of 2.9 crashes per year. And again, the goal of saying if these countermeasures will be effective is that less than the predicted number? So before, our expected was above our predicted. If we implement these changes, our expected will be below our predicted. So that's how we can tell, yep, these countermeasures seem to be effective in terms of addressing the crash problem. The other thing that we want to talk about is the benefit cost analysis. And so quickly, if we recreate the project summary, so we just click that yellow button again, now that we've checked benefit cost analysis, we'll get a few new sheets will pop up for us. One of them is our benefit cost analysis sheet. So what we can do is we can come in here and say, what did we do at the site? So the first thing that we did is realignment, and then the second thing is add left turns. We need some basic information on service life and some basic information on costs. So we'll say 920. And then we'll actually end up with a benefit cost ratio for this site. So we'll say, yep, we know that from our report, we understand that this will reduce our expected crash frequency below the predicted, and then we can implement some basic financial information on the project, and we'll say, yep, we can understand that there is a positive benefit cost ratio. So figuring out the cost of the benefits and all that, ECAT will take care of that for us. So both of these implementations are Part C CMF implementations because there are things that we can adjust in the site-specific calculations. If we wanted to look at a Part D CMF, we'd go back to the project information tab, and below our project element table and below our traffic forecast table, we have other non-site characteristic-based countermeasures. And we can kind of scroll through these and see these are our Part D CMFs that we want to look at. And so these are things that can't be captured with the Part C CMFs. So we can pick one. I don't know. We can look at provide flashing beacons at a stop-controlled intersection. So if we select that, some information pops up here. It'll tell us, what sites can we use this at, and there's a little code here. But then if we go back to that project element, so we go back to our proposed conditions and we keep scrolling down, we can now see, oh, here's that Part D CMF we selected. Let's apply it to our site. And as soon as we click that X, it applies it to our site. And then if we go back to our report, our expected crashes are lowered even more. So we were at 2.9 before the Part D, and now we are at the 2.6 is the final by implementing the Part C solutions of widening and realignment, and then the Part D of providing the flashing beacons. All right, so that's a quick example, beginning to end, of how we could do a full analysis and get kind of the benefit cost ratio. Again, ODOT has a lot of information online to help guide you through it, other than to guide you through the ECAT tool itself, but we want to make sure that we are comfortable and have the HSM handy to answer the more technical applications of how we look at any individual site. All righty, Cindy.
Yep, Alex, before you move on, we do have one question for you. And the question is, if you were to come up with multiple countermeasures, is there a way to have separate tabs with each countermeasure, or would you have to re-enter the proposed data for each different option?
That's a great question. So you can do it a number of different ways. I'd say the easiest way, if you're going to show different countermeasures, is to just copy and paste your base file. That allows you to kind of to have two concurrent versions of, hey, if we go with CMF Plan A, it's contained in this Excel document, and if we go with CMF Plan B, it's contained in this document. That'll help you. That'll be easier to keep the cost benefits straight when we start going down the BCA realm, but it will kind of help you from having to keep changing and replicating baseline information. The other thing that'll help with is on this project information tab. It'll keep this from getting very cluttered, because if we have the same NLF ID and the same log point, ECAT would struggle to assign those to both sites at the same time. This is really meant for looking at one project at a time. And so I would recommend breaking down to different Excel files.
That would have been my response as well. I was kind of curious as to what you would think. It's a broad question, but to the point where you were just showing the example that they had, that you put one of those countermeasures down below into the mix. If you had multiple countermeasures, if you could scroll down really quickly, Alex. If you had multiple countermeasures in the non-site characteristic base, then you could toggle in between, in on and off in the individual files in order to move those around. If you are going to do something, though, that is related to a CMF that is such as one of the ones that's a Part C CMF, then it wouldn't be changed here. Of course, you would have to change the actual element tab to reflect that difference in that particular condition. But again, in this case, we're doing these are the non-site characteristic situations. So you could toggle on and off between these, between the different analyses files, correct?
Yes.
So basically you would just say, you could have all of your countermeasures here, but you could just tell them which ones you were going to use for this particular alternative.
Correct. And so ECAT, Derek said it the best, ECAT really only allows for one alternative to be analyzed at a time.
Yes.
But yeah, and I'll just add, you can have 4 countermeasures total for any specific site element. So after that point, the true safety benefits of adding another one is really unknown, because you're changing the existing site so much. So we limit it to 4. Other states or jurisdictions limit it to 2 or 3, but right now Ohio is limited to 4 at a time.
All right, anything else on ECAT, Cindy? I know it's a lot to take in, but it's definitely a very user-friendly way to go through all of our steps. We didn't have to worry about, we didn't have to think through like, okay, now I need to do step 1 of Part C, step 2 of Part C. We just had to go through the ECAT process, and it kind of does it all for us.
And when you're doing this type of analysis, definitely reach out. Again, we're going to repeat this multiple times to your district safety coordinator if you have a question about that and how to do that. They're your greatest resource in order to figure out how to navigate through ECAT while you're doing the alternatives analysis. So do it while you're actually doing the analysis rather than waiting to the end, and they'll be more than happy to help you. Alex, that was the only question that we had.
Okay, great. I'm going to jump back into our presentation then. So the last step of the process is to develop our plan and finalize our report. Everyone should have the handouts for all 4 of these modules. If not, they're available in the documents portion of the GoToWebinar toolbar. The last portion of this, and in step 5 in the process, we're going to offer some general guidance and advice on how to put this together, but definitely good to keep these notes handy as you're going through scoping and developing your final report. So again, we're in step 5. We've done all the analysis at this point. Now we need to turn it into a physical and digital safety study. So we want recommendations to be based on PSI. If we do our analysis and the site does not have a potential for safety improvement, we need to immediately stop and kind of have a conversation. It might be that we document that in the safety analysis, in the safety study, but we definitely want to have that conversation. Recommendations really should consider engineering, enforcement, driver education, and other factors. I know ECAT and the HSIP process are heavily focused on infrastructure, but this was a conversation that came up, I think maybe in the first module, if not the second. What if we do our CAM tool and there's a lot of alcohol-related crashes? Well, this is how we document. We want to make sure that that's captured and that we're saying, hey, we need to do some coordination efforts, or it's going to be more than just infrastructure. And then the actual recommendation should be based on the knowledge of effectiveness of the proposed improvements, AKA running through ECAT like we just did. There needs to be a basis for proven implementation, and there needs to be that demonstrated application to our site or sites. So a combination or a different menu of improvements may be the best plan for addressing a location. It may be, more than just one fix. It may be an infrastructure and behavioral combination. But the big thing is all practical improvements, including doing nothing, should be identified and considered and analyzed. So if the only solutions are really expensive long-term solutions for addressing our particular crash type, we need to have that conversation in the safety study and talk about in the short term, what does it mean to do nothing? And what are the alternatives to kind of work past that do nothing? And even though an alternative may not be desirable by the city or DSRT, it's still probably good to mention that, hey, we talked about this and it was not included for reasons X, Y, and Z. So there's 2 study report formats. There's the full study and the abbreviated study. This is definitely something that'll be discussed, if not before, at the scoping meeting. Full studies are typically what we're doing as consultants and in support of local agencies or state projects. The abbreviated studies are really, those are usually coming from central office on-call contracts, or for situations where we know that a full study has been done and we're really going back just to update that full study and see what's happened in the few years since that study took place. So we'll go through each of these elements for the full study, but we'll have title page, the 1-page project summary, which is a requirement for funding as well. Our executive summary, including purpose, background, overview of possible causes, excuse me, and then recommendations and costs. We'll have a purpose and needs section, existing conditions, crash data, and then our crash analyses. We'll then talk about other transportation analyses and results, which is the summary of the relevant traffic studies. Our proposed countermeasure evaluation, which is where we'll talk about the countermeasure descriptions and what is their potential for improvement. So what is their proven effectiveness? And then we'll talk about the countermeasure cost analysis, and then our benefit cost analysis results. And you can see how a lot of this is going to come from selecting appropriate countermeasures, identifying their related CMFs, developing a cost estimate, and then running through ECAT. And finally, we'll include conclusions and recommendations and prioritization. And then appendices is a big one. A lot of the things that we want to include in appendices, let's have a conversation, again, DSRT locals, to see what do they need to document this. We do want to prevent getting, several hundred pages in appendices, which is really easy to do when you deal in data and analysis. So really want to focus on what's been completed, what was authorized, and what is requested or needed. But it could be everything from traffic counts, the actual crash reports themselves, the data and the analyses for our supporting traffic studies. Certainly our cost estimates is a good one to include. The HSM calculation results, or, in your mind now, let's think about the ECAT output. What does the ECAT output say? What are the benefit cost results from ECAT? And then photos, if scoped or if necessary, and if they really help. Title pages, everyone should be very familiar with including, district, the CRS, the county route and section. If your site came from a safety analyst results or screening list, include that, make sure to include your safety annual work program year. If you're not sure what that is, again, just talk with ODOT on that one. Study completion date, this is a snapshot in time. I think we've said that enough at this point, so understanding and documenting when these conditions were valid is important. Who completed the study, and then just an overview location map of where the study is. And here's just one example of a good looking title page. So the one-page project summary, this is really where we're trying to convey everything in one kind of engineering size drawing. We need the basics for the project information and location, highlight any relevant existing conditions, any major crash patterns, and what are the recommended solutions. So this is one graphic-driven page to kind of capture the entire safety study. So this is one example of a one-page summary. You can see we've got a high-level version of our crash table. We've got an overview map, some existing conditions, and then we're actually starting to draw out and show, what are the proposed alternatives. And the other information that's in here is really what's driving this safety study. If you're having a lot of crashes and it really is due to a capacity issue, then maybe you want to include that capacity analysis, or any relevant information to really and quickly show this is why we need this project. In this situation, the recommendation, I would say, we want to be graphic driven. Let's not worry about adding too much summary text to these. It should be really kind of easy to glance through and understand, okay, I see where we're at, I see what the problem is, and I see where we're requesting funding or where we're proposing to go in terms of alternatives. So this is another one. You can see these are all very much along the lines of a quick summary poster presentation. And so we have, again, this is where we have our alternative is overlaid over aerial imagery. We're showing typical sections in the proposed conditions. But again, very simple, not clouding it with too much detail. So in our executive summary, we need to make sure that it is brief, it is to the point, and it conveys all of the relevant results about the safety study, which again, we'll follow in the full safety study itself. This is something that we have to add. It's not something that we add as like well, this would be nice if we could get an executive summary, but we don't need it. It's definitely, we want to make sure that we get the executive summary in there and that it's complete in both background, purpose, overview of the possible causes, and then what are the recommendations. All right, so the first actual section of the main body of the document is our purpose and need statement. And this is, why did we study this location to begin with? And when we started looking at this study, what popped up in terms of the need for implementing countermeasures? Things that we want to include generally are in the purpose and need is if there's a safety analyst ranking or another network screening, let's say it was on an MPO list or something like that, we want to include that in here, and that's why this came up. We want to talk about when we did the crash analysis, look at, these are the issues in terms of safety based on numbers. And then we also want to bring in that potential for safety improvement. Major thing about the purpose and need statement is it should not cover countermeasures or proposed solutions. We'll get to that in the report. This is really just teeing up why we're here and what the safety problem is. So the purpose for the study and showing that there is a safety need. Easiest way to show there's a safety need is, again, finding that potential for safety improvement from the EB methods and ECAT. So in our existing conditions, I think, the tendency is that there's a lot of conditions at any given site. So let's focus on the ones that are relevant and impacting safety, or the ones that are explicitly not impacting safety. So, if the site is really well lit, we did a daylight and a nighttime site field visit, and we know that it's really well lit, then we're going to want to document that there. So we're not going to start wondering like, well, is the lighting sufficient? But we definitely want to talk about, the obvious background stuff. Where is it? This is in detail a little bit more. what type of facility are we talking about? Let's set the table for what analysis is appropriate. You know, I just want to talk about what's the history of the traffic control, what is the history of the crashes. So at this point, we're going to want to talk about what is, you know, why again did we get here a little bit? It's in the purpose and need, but let's include the previous improvements. So not just like the immediate history, but has the site been studied? Did we understand that there was a crash problem? What was done previously? What was implemented previously to address crashes? And again, it's the high level, what's going on. Our conditions diagram, we talked about that last week, but we want to just include the conditions diagram in the existing conditions. So that was covered in module 2. Again, this is a full list of potential things. You know, if it's applicable to our site, we want to include it, but let's not worry about checking every single one of these boxes in our existing conditions diagram. Similarly, we need a physical conditions write-up. This is one example. Hopefully everyone can take the time to read this in the slides, but we want to be succinct and not cover extraneous details, but we need kind of a narrative of what's going on out there. All right, so that's all in terms of physical conditions. You'll note crash data, we're going to go over our crash diagram. This is where we would include that. We talked about the crash diagram back in module 2. A general crash summary, and we're talking more of a narrative. What are those bullets that we developed in the crash analysis process back in step 1? And in step 1, we also we developed a lot of analysis graphs or tables. And so we want to make sure that we're including those as needed in the body of the report as well. I think, you know, we covered last Friday, let's not overwhelm the report with every single chart that we can make. We want to use what we need to convey the purpose and need of the study. But again, this is a list of potential things to include. So one of the other things in terms of countermeasures that we want to consider, there's a lot of different sources for countermeasures, but let's make sure that we're considering a wide range of them instead of going into the study with, we want to put in a roundabout and we don't consider the other alternatives. So definitely make sure you're familiar with a larger body of countermeasures and strategies, definitely along the lines of national publications, the Highway Safety Manual itself, CMF Clearinghouse, NCHRP and FHWA reports, and then other past implementations also help too. All right, so once we talk about our crash analysis, this is a good time to bring in those other analyses in step 3. As we talked about earlier, we want to show the results of those other analysis in the main body of the document and not necessarily tie them back to, we don't want to go into too much detail. We want to say, why do we conduct these other analyses and how do they impact the safety performance of this site? If there is, you know, we can talk about what the data was collected and how it was analyzed, but those details really should be left to the appendix. So we're just looking for the summary of the results. And again, the correlation to crash patterns and countermeasures. The next section of the full report is the proposed countermeasures evaluation. This is where, again, we want to discuss all evaluated countermeasures and identify proposed countermeasures. So we want to discuss them all, even if they are not have not been pushed forward to, you know, we want to implement this or we want to start talking about cost analysis. It's a great time to talk about why we're not entertaining certain countermeasures. Those questions will come up in the future and they may come up when we go to apply for safety funding. So always good to have that documented. In terms of developing the cost estimates, we want to determine cost estimates for all recommended countermeasures. This is the difference. We can identify potential countermeasures, but if those are not going to be recommended for implementation, let's not waste any time developing those costs. If there's immediate barriers to using those, we don't need to develop a cost and present that here. The other thing for cost estimates is they should be robust enough to be realistic. These aren't, you know, design level. There's going to be a design for particular major projects, but let's be cognizant of things like right-of-way. It's pretty easy to go to a county auditor's website, pull the right-of-way that's available and see, is there going to be a major right-of-way cost? And that assessment, usually good to ensure that the recommendations and cost estimates are feasible. Obviously, we're dealing with planning level costs here. Not necessarily, you know, design level, but we want them to be representative And we don't want to come back after we go through this process and say, oh, we're off by a factor of 2 or 3 on that cost. And so then again, after that, we want to present the benefit cost analysis results. And to be honest, those should be pretty well summarized in ECAT for the report itself. And in conclusions, let's come up with a summary again, definitely shorter than our executive summary at the beginning. But why were the crashes occurring? What infrastructure deficiencies were related to the crashes? What was the body of countermeasures evaluated? Why were they dismissed, and why? Again, we really just want to talk about when we get to recommendations and prioritization. The conclusions need to say, this is everything that we considered. This is why we're here, and this is why we didn't include certain countermeasures for recommendations, despite the fact that they're identified. Recommendations and prioritization is now, okay, of all the countermeasures that we looked at, these are the ones that we want to implement. And we would recommend implementing these. A range of strategies is generally what we want to talk about, both in terms of short-term countermeasures, so under a year, medium term, which is 1 to 5 years, and long-term, which is over 5 years. And that can help us develop kind of an implementation strategy. So let's do the short-term, low-cost things now, reevaluate the baseline safety performance a little bit down the road, and then have that long-term solution kind of teed up, ready to go. But we also want to make sure we're discussing the effectiveness of these different alternatives and then how they're going to impact traffic and site conditions. So the proposed conditions diagram, we saw one in the in the one-page summaries. These are great ways to kind of convey, here's what we want to do. Again, we're looking at planning level sketches here. These aren't, design documents, but it helps to show where is our current existing right-of-way. Here we can see that the widening that we're proposing here is going to go into is going to leave the existing available right-of-way, so there's going to be an acquisition needed. But overlaying the design or the proposed conditions over aerial imagery is definitely the easiest way to kind of say, here's what was out there and here's what we're proposing. The proposed conditions diagrams, again, can be a little bit more comprehensive if we have a lot more going on. It's really right-sizing the need for this with the local highway agency and with DSRT. Here's another proposed conditions diagram. This is for either an arc cut or a median U-turn. I can't say I've looked long enough to know, but we can see that this is a little bit more complicated in terms of the line work and identifying signs and streets, but not a whole lot of information in terms of the nitty-gritty. So again, we've talked about appendices earlier, but definitely want to include traffic counts if they were done. That helps you in the future. It helps the local agencies in the future, helps district, everyone, when they refer back to this project, having those traffic counts available will help to understand how that has changed. Crash data reports if requested, so the CAM tool output, and then other data, other traffic and safety data analysis. Again, we've covered this briefly when we were going through the contents, but the biggest thing with the appendices is include what's important and valid, but don't unnecessarily add to the length of the report by including things that don't directly tie to results or conclusions of the safety study. So the abbreviated study format is obviously slightly shorter, but the general default is that we're going to assume that we're doing a full study until ODOT or district or perhaps our local partners specifically tell us that we're going to go with an abbreviated study. Usually this is held to internal reports or task order contracts only. So in this case, we have the title page, overview, implementation, and then appendices. So we're really cutting down on the extended descriptions of why we're here. Generally speaking, we know why we're here, but we're just trying to get to what's a high-level overview and what countermeasures are we recommending and why. Title page is, same thing as the full format. The overview, we want to have an existing conditions diagram, but we don't need to go into an in-depth discussion necessarily on our existing conditions. And then crash data, we really want to limit to the pertinent details. We don't need to have that narrative summary necessarily of prevalent crash patterns or anything like that, but we do want to include a crash diagram. Crash diagrams are the #1 way to convey the crash problem. And then we also want to include ECAT if that's outlined in the scoping with ODOT, with your DSRT, and with your local partner. Some abbreviated applications, if we know the HSM analysis has been done, they may just say, we don't need that for this case, we're just updating another study. So definitely have that conversation in the scoping meeting. Other traffic analyses, typically we'll try to keep those out of the abbreviated applications, and that's one of the benefits of this, but if it's in here, definitely just comment lightly and how it applies to your traffic patterns again. And then just a brief summary on probable causes of our crashes. The implementation plan, this is those recommendations that we talked about before. This is where we're really going to do a high-level version of that. We're going to get right to which countermeasures have been completed. That's really important, particularly for sites where we know that a safety study was done. And then we're going to offer up that menu of countermeasures for recommendations in terms of short-term, medium-term, and long-term. It'll help here to identify if there's a short-term countermeasure that has already been implemented. That's why we're including those completed countermeasures and this index of countermeasures kind of in the abbreviated, is to understand, what have we done and where do we need to go next. This index of countermeasures may be as simple as updating the previous recommendations from a full study. And then in the appendices, we're definitely trying to keep these shorter. So traffic counts, if they were completed, crash data printouts, I would definitely, let's keep that to the pertinent amount. This is a situation where, we generally know what's out there, and the crash data that we need to look at is updating. Have those trends changed with a previous implementation, or have they changed even though we weren't able to implement anything? And then again, if applicable, we'll include those other traffic studies and data analyses. So that's a quick run through on what we expect out of the full report versus the abbreviated application. Both of these are detailed in, both of these are outlined in greater detail in the ODOT safety analysis guidelines. So definitely use this as a reference to see, okay, this is the order and the difference between perhaps a full and abbreviated, but want to make sure that we're referencing that ODOT safety analysis guidelines in development of this report. Alrighty, so that is the end of Module 4. I really appreciate everybody's time and sticking with us. I know we've covered an awful lot of information and seemingly a pretty short amount of time, but at this time, I guess we can open it up to questions, or Cindy, anything else come through in the last 20 minutes or so?
No, there are no new questions as far as I can see.
All right.
Yep, at this time, we do not have any additional questions.
All righty then, Mike, I don't know if you want to kind of give a refresher on the quiz and stuff.
Sure. So those individuals who have attended and completed all 4 sessions of this safety studies course will receive instructions on how to take the online test. So please look for that email by Monday afternoon with those instructions. And Alex, Cindy, any other closing comments?
If we didn't say it enough already, definitely just make sure that there's an open conversation with your ODOT district safety representative and your local highway agency partner.
Definitely, and I don't know if Derek Troyer is still available.
Yes. Hi, this is Derek. So I just want to thank everybody for their time attending this course and their interest in safety in Ohio and around the country. If you have any questions, feel free to reach out to me again, or the districts, or anybody else on our team. We also are working on updating our training globally, which which will not impact your traffic academy or your pre-qualification thing that you've just completed, but there will be additional resources coming over the next couple of years. Also, within LTAP, they do have an e-learning module, so just check out other training opportunities there. GCAT's over there. We do TIMS and GCAT live webinars every other month or quarterly, something like that. So be on the lookout. If you have questions today, there could be training out there to help you continue forward. So thanks again.
Thanks, Derek. We just had a question arrive. Will these videos be available to rewatch? The answer is yes. We have been recording these webinars, and we will send out an email with links to those videos on YouTube. So if there are any other final questions from the panel or comments? Okay. If not, thanks again everyone for participating in this training. We really appreciate it. Take care.